Oh yes, the magic of the latching relay. I have scoured the internet for a simple solution to just making a safe start mechanism for my milling machine. And I have a variable frequency drive, and I explained a little bit about that in the last video, and we'll have more videos of those. But first, I want to show you a simple latching relay. This is just going to be a 120 volt start relay, just to make sure that if something happens and the power goes off, well, my mill will not start spinning up on its own. And it's really simple, and I'm more of a practical application kind of guy. I can look at a schematic and kind of see what I'm looking at, but it doesn't always just kind of click. This is what this video is all about. All right, the latching relay. If you flip this on, current will begin to flow. Right? Nowhere to go. Relay is not closed. It can't flow through the contactors. Can't go anywhere else. Momentary switch is not pushed. This is hard on and off. This is momentary. It means it'll spring back. It will not stay shut. The moment you press the momentary switch down, current can pass through the switch. See this Y right here? It'll travel through the Y, and these are the coils of the contactor. The coils of the relay, I should say. The electromagnetic device that'll pull the relay shut. Once that happens, it closes. Relay snaps down, makes contact with these two contacts and these two contacts. Now that that happens, current can then flow through, actually it'll flow through the contactor, back through the coil, and this way. It's fighting focus because of my fingers, I apologize. But so the only way to disconnect it is a power loss from your power company, or you flip this off switch. And what that does, it keeps you from having an unexpected startup on your device, say an important milling machine or something dangerous. You know, you wouldn't want to be trying to fight to turn a circuit breaker off or look for a candle in the dark, and your machine all of a sudden come back on because the power was restored. Cannot happen with the latching relay. And almost all of your equipment that you have in your shop, like, well, all of my stuff anyway, you hear a big thunk when you go to push the start button, and that's the contactors closing, slamming shut. And let's build this and see what happens. All right, so here it is. And I want to point out a note on safety. I realize that this system is not properly grounded. I just want to show you the workings of the latching relay. It's really quite simple. Basically, it just Y's off of the main on-off button. It Y's again off of the output of the momentary switch. Both are going to contactors. Both are only one side's going to a coil, but both are going to the switch. So hard on-off switch on the hot in, hot out. Y's to contactor. Y's to momentary switch. Momentary switch Y's to coil, and then continues on to the contactor. So neutral's coming on the back. It's just attached to the coil. Let's give it a go. Now I'm being very careful. I realize this is an unsafe practice. If you don't feel comfortable with something like this, by all means don't do it. I'm working with 120 volt, enough to be unpleasant. Okay, switch on. I thought this was going to be lighted. It's not. It's a bummer. All right. Nothing happened with the relay, obviously, until I do this. Latching relay. Now we'll flip it off. Relay snaps back to normal. Let's go to on and latch the relay. Uh-oh, what'd I do? Oh, I gotta turn it back on. Now, how the heck am I gonna make this with 240 volts? All right, I should mention that the coil is 110 to 120 volts, and that is the only voltage you can supply to the coil. Again, the coil is here, and where the neutral is attached to the backside. So kind of fun. I was searching for this because I wanted to make sure that I could de-energize my variable frequency drive when I wasn't using it, or in the event of a power failure. That was the main safety feature that I wanted. So The VFD I ordered was 240 volts. I just thought it would use a lot less amperage, and it does. I mean, it'll, I think, full tilt at 240. Let's just say that I had I don't know, like a huge fly cutter in the mill, and it was nearing the capacities of the milling machine. It would pull 11 amps, all the while the milling machine is pulling almost 4 amps. So, I'm not an electrical engineer, but that's kind of the basics of what I understand of how it all works. A lot less amperage on 3-phase. So this was just more of an exercise in, some practice for electronics for me, and I hope you all found it helpful. Thank you.